Hi friends and neighbors, welcome to the 18th Shepnotes video, which is part 5 of a series covering statistics and probability. This video will look at the important subject of factorials. For any positive integer n, its factorial is the product of all positive integers less than or equal to n. If n equals 5, for example, the positive integers equal to or less than n are 5, 4, 3, 2, and 1. By definition, the factorial of 5, expressed as 5 exclamation mark, is 5 factorial equals 5 times 4 times 3 times 2 times 1, which is equal to 120. A value followed by the exclamation mark indicates its factorial. A general expression for the factorial of n is n factorial equals n times the quantity n minus 1 times the quantity n minus 2 times the quantity n minus 3, and so on until you get to 1. For n equals 5, factorial n equals 5 times 4 times 3 times 2 times 1, which is equal to 120. Factorial 0 is defined as factorial 0 equals 1. How is this justified? There are n factorial ways to arrange n objects. Each way is called a permutation. Let's see some examples. For 3 factorial, which is equal to 6, as shown in the top row of objects, there are 6 different ways to arrange these objects. For 2 factorial, which is equal to 2, there are 2 ways to arrange 2 objects. For factorial 1, which is equal to 1, there's only 1 way to arrange an object. And when there are 0 items, there is only 1 way to arrange these, and that is with 0 items. Another reason to see why 0 factorial should be equal to 1 is to complete the pattern for the known factorials. We know that 4 factorial equals 5 factorial divided by 5, which is equal to 120 divided by 5, which is equal to 24. 3 factorial is equal to 4 factorial divided by 4, which is equal to 24 divided by 4, which is equal to 6. 2 factorial is equal to 3 factorial divided by 3, which is equal to 6 divided by 3, and this is equal to 2. 1 factorial is equal to 2 factorial divided by 2, which is equal to 2 divided by 2, which is equal to 1. Therefore, if we continue the pattern, it seems like 0 factorial should equal 1 factorial divided by 1, which is indeed equal to 1. Now we reach a point where using the pattern breaks down. Following the pattern, minus 1 factorial would be 0 factorial divided by 0, which would leave us to believe that minus 1 factorial is 1 divided by 0, which cannot be justified in any reasonable argument. The notion of factorial works perfectly until 0 is considered and everything falls apart. 1 divided by 0 is never allowed. Another example where 0 becomes the fly in the ointment is when you consider this. X to the y minus y power is equal to x to the 0 power. Since x to the y minus y power is the same as x to the y divided by x to the y, that is equal to 1. So it follows that x to the 0 must equal 1. It must be true even though it doesn't make sense in the practical world. Mathematicians define x to the 0 equals 1 and 0 factorial equals 1 without mathematical proof or justification to prevent the breakdown of useful mathematical operations when the values are set to 0. Now let's take a closer look at factorials and see if we can discover some useful properties. Pause the video for a moment while you note and understand the fact that since 3 factorial is 3 times the value 2 times 1 and 2 times 1 equals 2 factorial, then 3 factorial equals 3 times 2 factorial. Be sure you understand that n factorial is always equal to n times n minus 1 factorial, and this can be extended as far as you need to something like n minus 1 factorial equals n minus 1 times n minus 2 factorial. Looking further into the properties of factorials, note that a factorial like 6 factorial can be expressed as 5 times 4 factorial, or it can be expressed as 5 times 4 times 3 factorial, or it can be expressed as 5 times 4 times 3 times 2 factorial, which is equal to 5 times 4 times 3 times 2. Any factorial can be expressed as various combinations of the factorials contained below the first value n. As we proceed with our studies of probability and statistics, fractions of factorials like 5 factorial divided by 4 factorial or 250 factorial divided by 249 factorial will need to be calculated. 5 factorial divided by 4 factorial is equal to 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1, which is equal to 120 divided by 24, which in turn is equal to 5. This is doable, but consider this one. 250 factorial divided by 249 factorial is equal to 250 times 249 times 248 times 247 down to times 1 divided by 249 times 248 times 247 times 246 down to times 1. Calculating factorial fractions manually is very time-consuming and prone to errors. Fortunately, there are some easy ways to get around tough calculations like this. A solution for many factorial fractions is the small hand calculator. Many of these calculators handle factorials for values up to 69 factorial, but get errors on higher values. My TI Inspire CX handles factorials like 250 factorial divided by 249 factorial, but fails with factorials like 2500 factorial divided by 2499 factorial. Another solution is the Excel spreadsheet with its function, which is typed into a cell as equal to FACT parentheses 170, where 170 is the largest value it can handle without an error. The statistical app on my iPad also develops errors with values greater than 170. There is a practical upper limit for any computing device, but let's look at a simple trick that allows you to calculate fractions like these in your head. The trick to calculating factorial fractions is remembering the simple fact that the factorial of any value is equal to that value times the factorial of the value directly below it. For example, 5 factorial is equal to 5 times 4 factorial. To calculate 525 factorial divided by 524 factorial, note that 525 factorial divided by 524 factorial is equal to 525 times 524 factorial, and that is all divided by 524 factorial. And the answer to this is 525. This is because 524 factorial divided by 524 factorial is equal to 1 and can be ignored. Pause the video and study the calculations on the screen until you understand this. When dealing with factorial fractions, a lot of tedious calculations can be avoided by adjusting the representation of values to allow as much cancellation as possible with values in the numerator and denominator. For 20 factorial divided by 17 factorial, you should be able to write down the simplified expression as 20 times 19 times 18, knowing any of the remaining parts of the original factorial expression, 20 factorial, are included in 17 factorial, which is cancelled out by 17 factorial in the denominator. Hi, friends and neighbors. Thanks for watching the 5th Shepnotes video on factorials. Understanding factorials is essential as you view the next video that uses factorials to explain combinations and permeability.